Welcome to clickmyproject.com. Now let's see about multi-scale image fusion using the undecimated Weyler transform with spectral factorization and non-orthogonal filter banks. Now let's see about the abstract. Here we fuse the image by the binomial wavelet transform. Our method spectrally divides the analysis filter pair into two factors which are then separately applied to the input image pair, splitting the image decomposition procedure into two successive filter operations. In pre-processing, we are applying Gaussian filter to our input image. Gaussian filter is often used to remove a noise from the image. Here we used VNR function to our input image. Gaussian filter is a windowed filter of linear class. The actual fusion step takes place after convolution with the first filter pair. Here the two images will be decomposition by controller transform. It will be separate image as a different subbands such as horizontal, vertical, diagonal and approximation. Then we set the filter value of the image. For each image we detect the directional edge of the image. For that we apply the convolution. Then we add the each directional image in the single variable. In spectral factorization, we extract the target region is based on the threshold and wavelet transform. The region is highlighted on the fused image. The each level of separated subbands is fused to the corresponding bands. Finally, we apply the inverse transform to fuse the images. This is the flow of a process. Here we have to give the two images as an input. So first image will be the infrared images and second image will be the visible images. So the both images will go to the process. So initially we are giving the input image to the pre-processing. In this stage, here we are removing the noise from the image. For removing the noise, Gaussian filter are used. It is the windowed filter with the linear class. Based on the weighted mean of neighboring pixel, the noise will be removed. After removing the noise, it will go to the controller transform. It is one of the method to transform the image to the coefficients. It is a filter band structure that can deal effectively with the piecewise smoothing images with smooth contours was proposed. The resulting image expansion is a directional multi-resolution analysis framework composed of a contour segmentation. So it is the extension of wavelet transform. Controller transform is a double filter bank structure. It is implemented by the pyramidal directional filter bank. After extracting the filter bank coefficients, we will get the two informations such as approximation and detailed information. For that approximation, we are going to the fusion. Both information will go to the fusion. For in the fusion, we are using the target extraction. So then we are extracting the brighter region from the infrared images. For that information, we are highlighting on that fusion. After fusing the information, it will go to the inverse controller transform. Inverse controller transform is the reverse process of controller transform. It is used to reconstruct the image to the original form. So after inverse controller transform, finally we are getting the fused images. Let's see the demo of our process. Here I am having main.m file. Select this file, right click and run the file. So this is our design. So initially we got to given the input images. Now I am selecting two images. First one is the infrared image and then second one is the visible images of that corresponding infrared images. So it will go to the denoising process. Here we are removing the noise from the visible and the infrared images. After denoising, it will go to the controller decomposition. This is a controller decomposition result of visible and infrared images. Next we have to move on to the spectral factor. So this is the spectral factor of our infrared images. This is the approximation, horizontal, vertical and diagonal informations are identified. And this is the spectral factor of visible images. It will give on to the further process. So we have to identify the region for target extraction, so that initially we are identifying the marker image. The target will be segmented based on the watershed algorithm. So this is the marker image for our input image, and then it will go to the segmentation process. These are the segmented result of based on the marker image, and then we are going to identify the metric value. So these are the metric value for the each region. Based on this metric value, we are segmenting the region from the area. After that, the segmenting result will go to the next process. Here we are fusing the approximation and detailed information also fused, and then finally we are showing the fused image. These are the fused result of infrared and the visible image. Here we are highlighting the person based on the target extraction. Here we are highlighting the, and then we are analyzing about the approximation and details. Structure similarity also identified, and then this is the structure similarity information, and then QAB similarity, this information performance graph is also shown here. Here I am showing the result of multiscale image fusion based on the controller transform. It's showing the better result than the existing system. Thank you.